Hello again, it's Mrs. Farmer back to do Chemistry Module 2, practice problem number 10. I am sorry, in number 8, at the very end I got cut off and I was showing you the answer and then someone called through, so it cut it off. But this problem, just so that you know, was worth, oh, whoops, lost my pen, 2 points, okay? So when you turn these homework problems in for me on Friday, that you can know for number 8, it was worth 2 points. But now we're actually talking about number 10. And it tells us that we have a 345 gram sample of copper. Now, I ran downstairs to get a mass. Did I pay any attention to grab a piece of copper? Of course not. So you should recognize this from our class on Friday. We used a variety of different types of metals. I just grabbed one. I should have grabbed copper, but I didn't. So pretend with me, please. At 100 degrees Celsius. So we're going to pretend that this is boiling hot, so I shouldn't be able to touch it. And it's dropped into a 4.5 calorimeter made of an unknown substance. So this is our calorimeter. Once again, we are pretending we do not know what this is, okay? Though I'm pretty sure most of you do know, but this is our calorimeter, all right? And if the calorimeter has 150 grams of water, so I just happened to bring some water here, they want to know, and they tell us that the temperature of the water changed from 24 degrees to 24.2 to 25.1. What is the specific heat of the calorimeter? Since we don't know what this is, remember, wink, wink, we can't look at a table. So I have these 3 things sitting out for you because I want you to just picture something. In our lab that we did not count that the calorimeter was going to take in any heat. For this problem number 10, we are. We're assuming that all the heat that this piece of metal gives off is going to go either into the calorimeter or in the water that is in the calorimeter, okay? So this heat given off is going to equal the heat gained by these 2 things, the water and the calorimeter. All right, and I have that written out here just for us to try to remember. The heat of the metal, which it gave off, and if we know it's giving off, it's a negative value, right? Is going to equal the heat of the water and the heat of the calorimeter, the heat that was gained by both the water and the calorimeter, okay? So got to keep that overall principle in mind as we are trying to figure out how to do this math. So I'm going to go ahead. Sorry, I'm not doing a good job of holding my phone. I lost my, I did videos last year for some of the other modules, and I had this cool stand, and who knows, maybe the girls took it to college. I don't know where it is. So I'm trying to just hold on to the phone right now. But let's go ahead and plug in what we know. They tell us we have 345 grams, 0.1 grams, I think, of our metal, which is copper, but we're pretending obviously that it's my dice, right? Okay, and at 100 degrees Celsius. So we're gonna know that its initial temperature is 100. Do you know how weird it is to write watching through the video, not looking at the paper? I'm not very good at that. 100 degrees Celsius, and it's dropped in a 4.5 gram calorimeter. So I can write that here. I'm sorry. Mrs. Farmer normally has better handwriting. Made of an unknown substance. So this is, we don't know, right? And it has 150 grams of water. So you notice, see how I plugged this out? I had the metals values, the water values, the calorimeter values. I strongly suggest that you get used to setting things up that way. It is the way it's going to be set up for you also on your test. So that way you can very easily plug in the values you know. All right, and the temperature changed from 24.2, so we're going to assume that that was the initial temperature, to 25.1. All right, what is the specific heat of the calorimeter? Okay, so a couple things you have to logically work out here. If that was the initial temperature of the water, that is also going to be the initial temperature of the calorimeter, right? Because those 2 are together. And if that's the final temperature of the water, then this is also going to be the final temperature of the calorimeter. Now that final temperature actually is going to be of one other thing. Because in the end, if you remember, we have our calorimeter, we have our water. We know the initial temperature of those was 24.2. Then we put a boiling hot temperature Remember, we have it down as 100 degrees of our metal, so we're pretending Mrs. Farmer has amazing hands there. We dropped it in there. We left it in there probably within 2 minutes. We had a higher temperature of that of being at 25.1. So that's the final temperature of the water. That's the final temperature of our calorimeter. It also then has to be the final temperature of our metal, because look, it's in there too. So that also has to be 25.1 degrees Celsius. Okay, so now we can solve for this. We can solve for that. Look at, we have all of our other unknown, all our other variables. That's the only unknown. And then that can work with us here. So I'm going to go ahead. I'm running out of space on my thing. So I'm going to try to just enter it in the calculator so you can see. Because we know what original, we're just multiplying those things together. So we're going to have 345.1 times 0.3851 times our final, which is 25.1, minus our initial, which was 100, and we have equals. Okay, so when we're looking at this, 4 sig figs, when we do this math, we're going to get, 3 sig figs. And so, because we each have a decimal place. So we only can have 3 then in our final answer also. So I am looking at a negative, okay, good. And I'm gonna write it right up here, negative, and that's, once again, trying to read that, 9,954. So 9,950 is what I believe, because we can have that number, that number, that number, that's 5 or less. I mean, that's less than 5, right? So we're just going to keep it as a 0. So we have 9,950, or we can put it as 9.95, make sure I keep it as a negative, times 10 to the third. And both of those would obviously be in joules, either one of those values, right? Okay, good. So we have that. Now let's move on to our water, all right? We have 150 times 4.184 times, do our subtraction here, which is going to be final 25.1 minus our initial 24.2, and our parentheses, hit equals, and we get a value of, whoops, ooh, that glare, sorry guys. 564.84. I look back and I see where we can have, this is going to be tricky. We're going to go with 3 sig figs just to make life a little bit easier for us. So we can have 565, right? Because of that 8, we can round up. So 565 joules, and that's a positive value. I know if you're looking in the answer key, which you should only be looking in the answer key if you're with your parents, it might tell you 600, but we're going to go with that. That's dealing with doing the subtraction separately and then counting it back in. Just go with the 3 sig figs. All right, so I know down here that the negative my metal is equal to the water and the calorimeter, the 2 heat, those gained, right? Because that goes back with what we talked about up here. So, sorry, this is getting to be a long video and I apologize. I want to rearrange this to just solve for the Q of the calorimeter. All right, because that's what I need to put in here so then I can solve for the specific heat. Long process, stick with me. So we're going to have to move around and subtract the water from both sides. So I have the negative metal minus the value of the water. So let me write in what we're doing here. Sorry, I had to try to write that. Okay, so when I plug that into my calculator, I need both negatives there. So it's gonna, watch, I'm gonna do that, parentheses, that, just so you can see what I'm doing, and my parentheses, minus 565. And if you notice, I get a positive 9,385. I only can do 3 sig figs, so it's gonna be a positive 9,390. 9,300, whoops, write it, show you where I'm writing, and 90 joules. So that is my value here. Once again, you could change that to sig figs if you wanted to, into scientific notation. All right, now I know to do this calculation, I didn't write this down, but C would be equal to Q divided by my mass and my change in temperature. Okay, so I'm gonna plug in over here. Make sure I'm following my steps here. Try to show you everything. This is getting tricky. All right, 9390 divided by my mass, which is 4.5, divided by, remember we talked about this in class because I am not using parentheses, okay? So you have to hit divided for the time for the temperature, and that's my final, which is 25.1, minus my initial, which is 24.2, and my parentheses, and then hit equals, okay? And I get the specific heat of 2,308. Oh, watch your sig figs, Mrs. Farmer. You can only have 3, so it's going to be 2,320 joules per gram Celsius. Okay? 2,320. That was tricky. The book, I believe, only gives 1 sig fig. Oh my heave, I don't like that as much. So that's why I'm gonna keep the 3 sig figs. So if you just had 2,000, that's okay. We can talk more about that in class, but it comes down with when you're subtracting your temperature and how many sig figs you have in that. And I would prefer to look at the original values because I put it in my calculator all at one time. So this one was worth 3 points, okay? So 2 points for practice problem number 8, 3 points for practice problem number 10. Please text me, email me, whatever, call if you need help with this. But hopefully you can go through, be confident in how we did both this and the other practice problems, so then you'll be ready for your test. Have a great week. See you guys Friday. Bye.